Hi, my name is Vaibhav Parshini and today we have Electronics Lab 4 video. So our task is to understand the VI characteristics of these diodes, which are Zener diode and PN diode. To apply the knowledge gained from studying these diodes, we have to design and analyze the half-wave rectification. So this is my ID. Let's just start with our experiment. For the first part of this experiment, I am going to connect this diode in series with this resistor, which is our 1K resistor, and I am going to connect channel A through this ADLM to provide a DC voltage, which is going to be vary, and through this multimeter I am going to measure the current, which is in milliampere. The current goes through this diode and this resistor. Okay, for the negative region, either we have to change the diode configuration or we have to change the connections. So I'm going to change the connections. The channel A. Okay, so now I'm going to check the negative region. So it is basically 0, right? So basically at 5 volt, the maximum volt, our multimeter shows that 0 milliampere current. So this is basically 0. This diode doesn't operate at negative region. So for part 4, we have to replace this diode to a Zener diode and this resistor to 200 ohm resistor. So I made another circuit right there. I am going to connect the channel A to the positive side of this diode and the ground to the resistor. It is similar to our previous circuit, and our multimeter is going to measure the current. flip this. For part 2, we have to construct a half-wave rectifier circuit using the diode for rectification, and we have to connect a load resistance for 10k. Across the output, we have to use the analog board to provide the DC voltage, which is 2.5 volt, and a frequency of 50 Hz in a pixel pulse. So what I connected here, that channel A, which is this yellow wire, is connected to diode, and the 2.5 volt is connected to end of this resistor, and in between of these diode and resistor it is connected a channel B. Now we are going to pixel pulse to measure the waveforms. Okay, so I'm going to change this to sine wave, and sine wave is to 5 ohm. Right. And frequency is to 50 Hz. Now let us see the waveform. Okay, so this is our rectified wave which we get. The negative wave is rectified, and this is our half wave rectifier. Now I will introduce a capacitor which is connected across between these node, between the resistor and the diode, and to the ground. Now let us check the output waveform generated by this capacitor. And I'm going to connect this, set it to 50 Hz. The rectified frequency or waveform which is generated. Now I'll set it to 100 Hz. Okay. 200. As I'm going to increase the frequency, our output voltage frequency is inclined towards the DC frequency. Now I'm going to set it to 100 Hz, 1000 Hz. Let's see what is going to be. Now so in part 3 I replace this diode to this LED, and this 10k resistor to 200 ohm resistor, 220 ohm resistor, and let us check the output waveform generated by this on pixel pulse.